Hello everyone, this is Mridul Agrawal. I am doing my MTech from Energy Systems in IIT Mandi, and I'm been teaching physics since last 3 years, and I have a good experience of teaching physics in a way so that it can be practically applicable as well. So today I would be talking about the projectile motion, and I would be calculating first the time of flight of the projectile, and then I would be calculating it through find the range of that projectile. So let's start. So here we can see that there is a projectile motion, and that projectile motion has a range of almost 19.86 meters and a time of flight of 1.53 seconds. So let's start from the new conditions as well. Let's say, so we can see that, and there is a projectile that has been projected at a speed of 30 degrees at a speed of 15 meter per second at an angle of 30 degrees, and we can find that the range from this calculator or this part, this measurer, is coming out to be 19.86 meters in a time of flight of 1.53 seconds. So first we understand what is the projectile. So if we see that the projectile is any particle or any object which is thrown into the air or any medium which is having a single acceleration, okay, which is having a single acceleration, which is mainly responsible for changing the direction of that projectile. So if we project a particle in a vertical direction as well, then also it is a projectile. If it is projected at some angle, it is also a projectile. So now we would be finding out the time of flight of this projectile as well, and we'll be finding out the range, that is the horizontal displacement of this particle from this origin point. Let's say we are considering this as an origin point. So here we can see that this is the velocity of the projectile, and it has a horizontal components equals to this angle is 30 degrees. So we can find it as v cos 30 degrees, and it has a vertical velocity as v sin 30. How it is being obtained? Using this triangle trigonometry. If we say that this is the perpendicular, this is the base, and this is the hypotenuse, then we can find that the base upon hypotenuse is cos theta is equals to cos theta. So if we say that the hypotenuse is equals to v, so we have b equals to s times cos theta, that is b cos theta. That's why I have written as v cos 30. Similarly, if we see that this perpendicular upon hypotenuse, so this perpendicular upon hypotenuse is sin theta. So this is equals to perpendicular is equals to hypotenuse sin theta, that is equals to v sin theta. Hope this part is clear. Now let's move on. So if we have a velocity, let's say 15 meter per second in this case, then we can see that this velocity is there in the direction which is making an angle 30 degrees. So first we need to calculate the time of flight. The time of flight is the time for which the particle is in air or in any medium, okay, and now it is again hitting it on the ground. So the time of flight is the time taken to reach this particle that has been projected from this point to this point. So if we need to calculate the time of flight, which is represented as capital T, then we can use a simple relationship, that is the vertical component will change into this v sin 30 in the negative direction, because it is, if you cut down this projectile inclined motion into these two directions, we can see that only in one direction it is having a velocity at a particular time, and in the horizontal direction we can see that like this. So we know that the vertical velocity, that is the v sine 30 component, will remain the same, only its direction is going to be changed. And this whole motion completes in a time interval that is capital T. So we know that the final velocity would be equals to v sine 30 minus v sine 30. Initial velocity is v sine 30 plus v sine 30 because it is in the upward direction, minus g. Why we are using minus g? Because the acceleration due to gravity is in the downward direction. So minus g into t. So we are using an equation that is v is equals to u plus a. Okay. So we have a time of flight is equals to this plus v sine 30 goes over there. So this is minus 2v sine 30, and we can find it as minus g. So we can see that it is equals to 2v sine 30 by g. So if we calculate this by this, 2 into 15 times sine 30, that is 0.5 divided by 9.81, it comes out to be 1.53 seconds. So from here we can find that this formulation or analysis has validated what we have got through this simulation or this experiment. So from this time of flight, we can find out range as well. So let's start finding the range. If we calculate the range, we can see that there is horizontal motion that is involved. Horizontal motion means that this from this point to this point, this is the final point, this is the initial point. The direct distance along the horizontal direction is the range. And range is a distance parameter, so it would be calculated in meters, centimeters, millimeters, or so on. So we need to find this range. So here it's the formula for the range. We can derive as follows. We know that S is equals to ut plus half at square. This is the basic second equation of motion. In the horizontal direction, we know that the distance covered is range, and the horizontal direction velocity is v cos 30. And what time is being there for reaching the particle to this point? So it is the time of flight t. From this, we can find out range equals to v cos 30, that is 15 cos 30 times the time of flight. So time of flight comes out to be, if we use the formula, then we can have 2 u sine 30, that is v sine 30, v sine 30 by g. Or if we use direct value of this that we have found in the earlier one, then we can find it as 15 cos 30 into 1.53 seconds. So this comes out to be, if you calculate it using a calculator or your basic calculations, then it comes out to be around 19.86 meters. So thus we can see that from the equations and from the experimental value, both the values comes out to be same, and it has majorly validated what we find in actual way as well. So hope this solution or the physics part in which I tried to uh, show you the experiment, how it is done, and I tried to validate it using the equations. This is clear. And if you have any doubts, do let me know. Thanks for listening.